We are now solving question number 7 for this work power energy for M1. A load is being pulled along horizontal ground from a distance of 76 meters using a rope. The rope is inclined 5 degrees above the horizontal and the tension in the string is 65 Newton. Find the work done by the tension part 2. And at an instant, the motion of the velocity of the load is 1.5 meters per second. Find the rate of the working of the tension at that instant. Since in this question, it has been moved 76 meters with a tension of 65 Newton, making an angle of 5 degrees with the horizontal. And you are going to find out the work done by the tension. We will first resolve these components of this tension force. This is T sine of 5 and this will be T cos of 5. This is the normal reaction R to that part. This is the frictional force of that, which is equal to weight, and this is the frictional force of this portion there. Since the tension T is equal to 65 Newton, so for the first part, work done by the tension is equal to force due to the tension into the displacement of that question, which is equal to T cos of 5 into D, that is equal to 76. So this will be equal to T is equal to 65 cos of 5 into 76, and that numerical value is equal to so this is the force we have resolved tension into the two components T sine of 5 and T cos of 5, and now we are going to find out the work done by the tension, which is equal to driving force of the tension into T. So it should be equal to 4920 joules. For the second part, rate of the work done. Rate of work done means what? Power. So power is equal to driving force into velocity. So driving force is the tension force, which is T cos of 5 into resistance force. Distance is there 1.5, but T value is equal to 65 cos of 5 into 1.5, and that thing is equal to 97.1, and the units for the power, that is watt. So these are the two parts of this question which is being explained in this part. One is known as to be called the work done by the tension, and other is the rate of the work done by the tension. So that is equal to 97.1 joules. Now we will solve question number 8. An object of mass 8 kg slides down the line of the greatest slope of an inclined plane. Its initial speed at the top of the plane is 3 meters per second, and the speed at the bottom of the plane is 8 meters per second. The work done against the resistance to the motion of the object is 120 joules. Find the height of the top of the plane above the level of the bottom. Since in this they are asking about the height above the plane, so we know one thing, that the work done by the driving force minus work done by the frictional force is equal to change in kinetic energy of the system. Because it is coming down, so potential energy will be lost, so it will be equal to mgh. But work done by the driving force, because there is no force acting apparently on the object, so this would be 0 minus work done by the frictional force, which is 120. That thing is equal to half mass of that is 8 into 8 square minus 3 square minus mass is 8 into g is 10 into the height h as it is there. So this will become minus 120 is equal to 4 into 64 minus 9 minus mg, that is 80h. So 80h will be equal to plus 120. So that thing is equal to 80h. Our height of that object is 340 over 80, and that thing is equal to 4.25 meters. It is the height of that object above the level of the bottom from the top of that. So this is question number 8 of that exercise, which we have done with the concept of the work energy principle.